Sample problem number 2 is a little bit more involved. There are little nuances, but I want you to go ahead and try it on your own first. And then I'll come back and I'll talk you through it and see how you did. So go ahead and pause the video and try sample problem 2. Okay, so what I'm going to do here is I'm going to simply graph these two lines. So I'm going to start off simply enough with 2/3. So I'm going to go up roughly 2/3. That's not a real pretty y-intercept. And then I'm going to go up from there 1, 2, 1, 2, 3. So that's a rise over run of 2/3. And then I can go down to 1, 2, and then go backwards 3. And so I more or less get that line roughly, and I'm going to come back and fill that in. Don't worry, I'm not going to leave it like that. The second thing I'm going to do is I'm going to say y equals negative x plus 1, so that's up plus 1, and man, that's almost right on top of that other point. I'm going to use a different color. And I'm going to go down 1 over 1, down 1 over 1. And I can graph that line as well. And again, I'm going to just simply use a highlighter. I'm not going to leave it like that. Now, you can clearly see that that's going to create a vertical line test issue. So what I'm going to do here is I'm going to look at my boundary. And my boundary in this case is a +2. So at +2, I'm basically creating just a barrier that I need to graph the two pieces on. So we can see on this one, 2/3 x plus 2/3, I need all of the x values that are bigger than 2. So I'm going to take that original line that was roughly right here, and I'm just going to continue that in that direction. Excuse me. And so if I had a straight edge, this would be a lot easier. So use a straight edge as usual. We ask you to do that. Computer's not being very cooperative. But you get a sense of what that's supposed to be doing. And then I don't need that highlighted part, and I surely don't need the additional points on that side. Then I'm going to graph the x value for negative x plus 1 for all the x values less than or equal to 2. And so that's going to be, and again, straight edge would be useful here. So be sure to use a straight edge when you're graphing this. Now, let's take a look at this one final part here. We have two pieces of these graphs, and we've got the right parts. But we have one final thing that we haven't addressed here. We need to actually deal with the 2 value itself. So at x equals to 2, we have the line, the barrier line, or the boundary line, if you will, that are being touched by both graphs. So we need to represent one of them as being equal to 2 and one of them not being equal to 2. So let's take a look. For the second line, x is less than or equal to 2. I know that I have that point right there, equal to 2. So if that one's equal to 2, what it tells me is that one on the red line cannot be equal to 2. And if you remember from graphing inequalities in Algebra 1, whenever it was not equal to a number on a number line, we used to represent that with a little open circle. And so that's how we're going to do it on piecewise functions, and this avoids the vertical line test because you're not having a repeating x at 2. So that's what a piecewise function looks like. I'm going to finish this by showing you how to do this on the calculator. Okay, so let's take a look at our calculator function. To graph a piecewise function on our calculator, what you need to do is look here to the right of number 9, and we have this little button here where we have a number of templates that we can use. Now, if you come over here to the right, you can see I've marked the piecewise function. Now, this first one that I marked is a template that only has 2 pieces for the function. The one right next to it shows 3, and what that's technically showing is that you can use that second one to determine how many pieces you want. It'll actually let you input if you want 2, 3, 4, 5 pieces of a piecewise function. But we only want to use the one that has 2 right now. So I'm going to go ahead and click that. And notice it gives me 4 spots. The first spot is for our actual equation, so I'm going to go in and put 2 divided by 3x plus 2 divided by 3. And then I'm going to use the tab feature to get to the second box. Now this is actually going to ask us for our inequality. And so here I'm going to do x is greater than 2, and the greater than symbol is right here above the equal sign, but it's a second function, so I had to hit control equals, and you can see that it gives me my choices here. So I need greater than 2. Now I'm going to tab down to the part below, and so now I'm going to do negative x plus 1, and I need to also do my inequality for that. Oops, sorry, should have done x first. So x is less than or equal to 2. Now that I have both my parts in there, I just simply hit enter, and you can see the piecewise function, and it looks very similar to what we have on our graph. Now, the only problem that you're going to find here is that it does not do an open and closed circle for you, so you're going to have to be aware of what that is, but at least it gives you a representation of the two parts of the graph. So that's your introduction to graphing piecewise functions. We'll look at a special case in the next video.